Hi everyone, this is the video going to do some revision with you, and I have a set of past year questions for the 2018-2019. Here I will only discuss on some selected important questions. So now here I have a question 1. A, given that the gx x plus 1 over 3x minus 7, we need to find the first derivative. And next, for the question B, we need to evaluate dy dx for this function when the x equals to -1. Let's see the solution. Find the g prime x, I need to apply the quotient rule. I let the x plus 1 to become the u and the b as a 3x minus 7. So just write down next to the question here, we can find the u. We set the u and the v first. Then we find the u prime and the v prime. U prime is equals to 1, v prime equals to 3. Then for the quotient rule, this is the formula we're going to apply. vu prime minus uv prime over v squared. So we just plug in all these u and the v. This is my v, and u prime will be 1 minus, put in the u, that will be x plus 1, and the v prime is 3. And all this will be divided by the v squared, that is my 3x minus 7 squared. Okay, so we need to simplify the numerator first, expand and simplify. I have my 3x minus 7 minus 3x minus 3 divided by 3x minus 7 squared. So this is a 3x minus 3x, I have 0. Negative 7 minus 3, I got negative 10, divided by 3x minus 7 squared. Alright, this is my first derivative of the gx. Okay. For the question B, need to find the dy dx for this y function. I have my y equals to x squared plus 1 power of 5. Alright, so I'll see this function as a two-layer function. The first layer is a power of 5. Second layer will be x squared plus 1. To find the dy dx, I'm going to differentiate layer by layer. The outer layer will be 5, power of 5. So how do we differentiate the power of 5? Normally, we'll bring the 5 to the front, and then the power then will be deducted by 1. So what is inside this bracket, I will just copy it down first. And then now we're going to differentiate the second layer. Second layer will be x squared plus 1. So differentiate x squared plus 1, I got 2x. Rearrange your question and simplify. You got the 10x multiplied by x squared plus 1 power of 4. Alright. But the question is interested on the dy dx when the x equals to 1. So then you need to substitute 1 inside. Into your dy dx, you got 1 squared plus 1 power of 4. Then you got 2 power of 4, that is 16. 16 multiplied by 10, that will be 160. Sorry for this question, they want us to substitute x equals to -1. So I would like to do some correction here. This will be my -1, -1, -1 square. -1 square still will be 1, 1 plus 1, 2, 2 power of 4, 16. 16 multiplied by -10, you got -160. The answer is -116. I will skip question 2, then come to question 3. So question 3 is finding the volume. Figure 1 shows the region bounded by the y equals to x cubed. This is a y equals to x cubed. And y equals to 8 and y equals to 0. Then we need to find the volume of the solid obtained when the region is rotated 360 degrees about the y-axis. Meaning that if your region of the shaded region rotate about the y-axis for 360 degrees, we're going to form a solid like that. This is a solid that we probably will get if your region is rotate about the y-axis. Alright, so you are going to get the volume of this solid. Now, To get the volume, we need to stick to the formula. Since the area, the region is rotated about the y-axis, we need to integrate x squared with respect to y and integrate the limit. The lower limit will be, let's see, from a to b. For this case, will be 0 to 8. All right. The limit also you need to be taken from the y-axis. For this case, we have 0 to 8. And what is the x squared? Because the question is given the curve y is equals to x cubed. All right. This region is bounded by the curve y equals to x cubed. To get the x squared, we need to write the x in terms of y first. I have my x equals to y power of 1 over 3. So what is your x squared? We square both sides. We will have 2 over 3. Y power of 2 over 3 will be your x squared. So now I just put in my x squared inside. That is my y power of 2 over 3. I'm going to integrate with respect to y. Alright. Then you integrate y power of 2 over 3. How do we integrate this? We just increase the power by 1. I got my y power of 5 over 3. Then divided by 5 over 3. The 3 you can bring up here. Alright. And then now you can substitute the upper limit inside. You have your 8 power of 5 over 3 over 5 minus 0. Alright. Substitute y equals to 0 inside. You have this term to be 0. Then now you can press your calculator. Here you have 96 over 5 pi unit cube. Because this is a volume, talking about the volume. Unit will be unit cube. Alright. Let's just move to the question 4a. I need to differentiate this function. This is a simple question. We just differentiate it term by term. Differentiate the first term, you got 0. Alright, constant, differentiate, you got 0. Differentiate 7e power of negative x. Alright, you have your negative. How do you differentiate the ex? Okay, here we recap a bit on the formula. Differentiate e power of fx. Will have a prime x, e fx. Meaning that any function e power of fx, you need to differentiate the power first to get your f prime x. And then you copy back the itself, that is your e fx. Alright. This is the formula. Now, differentiate first term, you got 0. Differentiate the second term, the 7, you just copy down. Alright. Differentiate e power of negative x, you have your negative e negative x. Which you differentiate the power, you got negative 1. And then you copy itself back, you have a e power of negative x. And now for the x e negative x, alright, for this term, we need to apply the product rule. Okay. So let's write down the negative sign first, and I put a bracket here so that later on the sign will be very clear on it. Okay, so now I put a bracket. So all my product rule will be put inside this bracket. So how do you differentiate the x e power of negative x? You are going to copy down the u first, that is your x, and then differentiate your v, that is your negative e negative x. So take note that here is a dot, means that these two is a multiply each other. And then plus, copy down the v, that is your e negative x, and differentiate the u, you got 1. So we close the bracket now. Just simplify it. You have your negative 7e negative x. Here is a dot, means that these two are multiply each other. Alright. So simplify, you will get negative 7 e power of negative x. And negative multiplied by negative, you have positive. Positive x power of x e power of negative x. And then negative multiplied by positive, you get negative e power of negative x. This is how we differentiate. Alright, then we can see that this one can be simplified further. We need to simplify it. Just copy down this term, and these two terms are the like term, so we just can combine them. Let's say this is represent an apple, then you have negative 7 apple minus apple, you have negative 8 apple. If you want to simplify further, this one just cancel it off. And then if you want to simplify further, you can just factor out the e power of negative x. You got your x minus 8. Okay. Proceed to the question 5a. I have to differentiate this function. So I will let this become my u and this become my v. And then I will apply the product rules. Alright. So if you feel confused, you just can write down what is your u. U can be your x squared. And the v is your ln 2x plus 1. Alright. Then get your u prime. Your u prime will be 2x. And the v prime is, how do you differentiate log? Differentiate any function log gx. Alright. You are going to differentiate the gx, get your g prime x first, and then divided by the gx. Alright, this is the formula to differentiate log. So now my gx will be 2x plus 1 compared to the formula. So you differentiate the 2x plus 1 first, you got 2, and then divided by 2x plus 1. This is your v prime. So your dy dx is going to be, okay, apply the product rules. You have this. Alright, product rule asking you to copy down the u first and then put in your v prime. Plus, copy down your v. And put in your u prime, that will be the 2x. Alright, then you simplify. You can simplify by writing this first term into 2x squared over 2x plus 1 plus 2x. I put it at the front of the log. 2x multiplied by log 2x plus 1. Then if you want, you can actually factor out the 2x. You have your x over x plus 1, 2x plus 1 plus log. Alright, this is my answer. This is the question 5b. 5b asking us to integrate a rational function, which is a x plus 2 over x squared plus 4x minus 1. Okay, to integrate this function, we can actually stick to the BSPD maybe. Or I'm going to use substitution method, because if I assume that the u is equals to x squared plus, if I let u equals to x squared plus 4x minus 1, I got my du dx equals to 2x plus 4. So 2x plus 4, if you take out the 2, you can see that you have 2 multiplied by x plus 2. And then later on, you can see that the x plus 2 combined with the dx, I bring up the dx to the right. This can be substituted as du later on. Du over 2. You can see that the x plus 2 dx, I bring up the dx to the right, bring the 2 to the left hand side. I have my du over 2. So this can be substituted as a du over 2. Alright, so this question is just perfect when you use the substitution to solve it. Alright, so I'm going to use substitution. I copy down the question one more time. So this will be going to be replaced by the du over 2. Over 2 means that it's a coefficient. I always can factor it out. And you have your 1 over x squared plus 4x minus 1. This can be replaced by the u. So you have 1 over 2 integrate 1 over u with respect to u. So you can see that the function, after you substitute the u as the x squared plus 4x minus 1, it becomes so much easy to integrate. Alright, so integrate 1 over u with respect to u, you have your log u. Remember to put the modulus. Okay, then finally, we're going to substitute the u back with your, in terms of x, which is your x squared plus 4x minus 1 plus constancy. Okay. For the question 6b, we're going to differentiate the function tangent e power of 2x. Alright, so I will see this function as two layers. The first layer is the tangent. I need to differentiate the tangent first. Then I will only differentiate the exponential function after the tangent. So firstly, we differentiate the tangent. We got secant square. And what is need to put inside this bracket is your e power of 2x, and never go and change anything inside the bracket. After that, multiply by, differentiate the inner function, which is your e power of 2x. How do you differentiate exponential? e2x, which you need to differentiate the power first. That is 2. Differentiate 2x, you have 2. And then copy back itself, that is your e power of 2x. Then we rearrange it, you will get your answer. Alright. Next, this is our question 6c. Given the y equals to 2 tangent x plus x squared, find the dy dx when x equals to pi over 6. So we just get the dy dx first. To differentiate this, I'll differentiate it term by term. I got two terms over here. Differentiate 2 tangent x, I have my 2 secant square x. And differentiate x squared, you got your 2x. So you need to find the dy dx when the x equals to pi over 6. So just substitute your pi over 6 into your x. This is the way I write. That is finding the dy dx when x equals to pi over 6. So just put in the pi over 6 inside. Plus 2x. X is your 2 pi over 6. Then secant square, you can actually change it into the 1 over cos square pi over 6. Okay. Okay, this one can be simplified. You get your pi over 3. Then what is the cos of pi over 6? Pi over 6 means that is 180 divided by 6 will be 30 degrees. The cos 30 will be a special angle, which you know that the cos 30 is equals to sec 3 over 2. Just put in the sec 3 over 2 inside. This is your sec 3 over 2 square plus pi over 3. Okay. Then you simplify this. You will have a 4, because 2 square is 4. 4 bring up, you have 8 over 3 plus pi over 3. Finally, you have your 8 plus pi over 3. You might leave your answer in a decimal number, which is your 3.71. Remember, must be your answer must be in at least 3 significant figures. For the section B, the question 1, you have given the y equals to y over square root of 2x minus 1. Okay, here's some correction. This is not y, this is 2. Okay, so the function is actually 2 over square root of 2x minus 1. You need to prove d2y dx2, that is a second derivative, equals to 3 over 16 y power of 5. First of all, you need to get your dy dx first. To get your dy dx, probably you can change this y in this form. Easier for you to differentiate. That is your power of negative 1 over 2. So differentiate, finding the first derivative. You have your coefficient 2, just copy it down. And then to differentiate this, you can treat this as a 2-layer function. First layer is your power of negative 1 over 2. The second layer is 2x minus 1. To differentiate the power of negative 1 over 2, going to bring down the negative 1 over 2. And then the power of negative 1 over 2, you're going to deduct by 1. You get a negative 3 over 2. Okay. So what is inside this bracket, you just put it into your bracket. And then lastly, you differentiate the inner layer. That is 2x minus 1. Differentiate 2x minus 1, you get 2. Okay, so now we can simplify by cancelling this 2 And now just write them in the proper way. You have your negative 2, 2x minus 1 power of negative 3 over 2. And I'm not going to write in the form of a square root, okay, because I still need to find your my second derivative. Okay, so this form will be just nice for finding the second derivative. To get your second derivative, that is a d2y dx2. Okay, the coefficient just copy down. And how do you differentiate this 2x minus 1 power of negative 3 over 2? Again, I will treat this as a 2 layers function. Differentiate the first layer. I will bring down the negative 3 over 2 and provide a bracket to put in your 2x minus 1 later. Then now, you will decrease this power by 1. That is a negative 3 over 2 minus 2 over 2. That will be negative 5 over 2. And now you need to differentiate the inner layer, which is your 2x minus 1. Differentiate 2x minus 1, you got 2. So we have done the differentiation. We need to simplify it. Cancel off the 2. I have my negative 6 over 2x minus 1, 2x minus 1. Okay, so this is positive. Okay, negative multiplied by negative is positive. 2x minus 1. Alright, power of 5 over 2 means that this is a square root and power of 5. So now we're going to prove that this is equals to 3 over 16y power of 5. Yeah? We're going to prove to this in terms of y. Alright, so from here we can see that if your y equals to 2 over square root of 2x minus 1. Okay, let's look at this. Y equals to 2 over square root of 2x minus 1. Meaning that the square root of 2x minus 1 here, it can be replaced by 2 over y. So let's look at this. I have the 6 on top, and the square root of the 2x minus 1, I substitute it by the 2 over y. And don't forget, this is power of 5. Then we simplify. Okay, so I have my 2 power of 5 will be 32. And then the y power of 5 I bring up. I got my y power of 5. Simplify further. This is 3, this is 16. Then you have your 3 over 16 y power of 5. And we say that we have proven. Okay, as requested by the question, we need to find the d2y dx2 equals to 3 over 16 y power of 5, and we have did it. Alright, so next we need to get value of x when the d2y dx2 equals to 6. Let's move that to the question. Hence, find the value of x when d2y dx2 equals to 6. Meaning that you need to get the value of x. So this is your d2y dx2. Then we equate it to the 6. Alright, this is a 3 over 16 y power of 5, which is your d2y dx2. We equate with 6, and then we solve it first. Y power of 5, 6 multiplied by 16 over 3, we got 32. Means that the y will be equals to 2. So now the question interested on the value of x when the d2y dx2 equals to 6. So what is your y? Y is your 2 over square root of 2x minus 1 from the question. Alright, this is your y. So I will equate it with the 2. So now you can see that this is a square root of 2x minus 1 equals to 1. We're going to solve this. Squaring both sides, you have your 2x minus 1 equals to 1. And I have my 2x equals to 2, x equals to 1. This is our answer. Meaning that when the d2y dx2 equals to 6, I have my x equals to 1. So next, come to the question, section B, question 2. Figure 2 shows the curve y equals to x squared plus 1 and the straight line 2x plus y equals to 9. Given P is the point of intersection between the curve and the line, whereas the Q is the point of intersection between the line and the x-axis. Firstly, we need to get the coordinates of the P and Q. So to get the coordinate of P and Q, so simple. To get the P, we just solve the equation of the quadratic curve and the straight line simultaneously. We got the P. And to get the point Q, we just substitute the y equals to 0 into our equation of the straight line. Alright, to get your P, I will equate them, which is solving simultaneously. I equate the quadratic line, equate it by this, with this y equals to 9 minus 2x, meaning that I will write this as this line as 9 minus 2x. I will solve this simultaneously. So I have my x squared plus 2x, 1 minus 9, you got negative 8 equals to 0. Trying to factorize. X, 4, 2, positive, negative. Alright, you can check back whether if you got the correct one. Then you have your x equals to negative 4. The other point is the other one is x equals to 2. And the x equals to negative 4 probably will be somewhere here. We don't see, the graph is not big enough. So this is your negative 4. And the other one, this is your x equals to 2. So we can say that the coordinate of the P, alright, having the x coordinate 2, and to get the y coordinate, we just substitute the x equals to 2 into the straight line equation or quadratic equation, is up to you. Alright, you have a 9 minus 4 that is equals to 5, meaning that the point P having the coordinate 2, 5. Alright, and to get the coordinate of the point Q, I just need to replace the y as the 0, yeah? Alright, to get the Q, I will equate this equation of this function of the straight line, equate it to 0, meaning that the y equals to 0, because this is the x-intercept. Then I will solve for the x. Okay, so x will be equals to 9 over 2. And to get the, so of course the y coordinate is 0. So the q having the coordinate 9 over 2 and the y coordinate is 0. Next, we need to get the area of the shaded region. So the area of the shaded region, we can see that this region is actually bounded by the two different curves, all right? And the two region, we can separate this shaded region into two different regions, which the first region is this one. I highlight with the red line. This is the first region that we can find by integrating the quadratic function. And the green color section will be integrate the straight line function to get the area. So we need to separate into two integral to get the answer. So B, to get the area, firstly, I got my red shaded region. I integrate from 0 to 2. And the function is the quadratic function because it's bounded by the quadratic function, which is my x squared plus 1. And integrate with respect to x. So this integral will give you the area of this first region. Second region will be integrate from 2 to q. Q will be 9 over 2. And integrate the, we're going to integrate the straight line function, which is 9 minus 2x. Integrate with respect to x. Alright, this second term, second integral, will give you the area of this second region, which is a triangle. Okay, so next we need to integrate. Integrate the first integral. I have my x cubed plus, over 3 plus x. Later on, you're going to put in the lower limit and upper limit. And this, for the second term, I got my 9x minus 2x squared over 2. And you can see that 2 can be cancelled off later on. Okay, so integrate from 2 to 9 over 2. So get ready your bracket just to put in your upper limit, substitution of the upper limit and lower limit. And the same for the second integral. Okay, So substitute 2, you have 8 and you over 3 plus 2. Substitute 0, you get 0. And 9 over 2 you put in, you have 9 over 2. Minus 9 over 2 square, you have 81 over 4. Put in the 2, you have 18 minus 4. Okay? Right, you get 131 over 12. 131 over 12 unit square for the area. For the question C, you need to get the volume of the shaded region rotated 2 pi radian about the x-axis, meaning that now if your area of this shaded region, rotate about the x-axis, you will have the solid and you need to get the volume of the solid. So let's try to sketch out what is the solid that you can get. You might get a solid roughly like that. Okay. Alright. This is the axis of rotation. So to get this solid, to get the volume of this solid, you need to separate into the two sections also. First, to get the volume of this region, okay, of this first solid, and we have a second solid. It's just like a cone. All right, we need to separate it and calculate the volume. So this is the formula to get the volume. So I will separate to find the whole volume, the volume for the whole solid. I will separate into two parts, which I integrate. The first part is from 0 to 2, and the other part is 2 to 9 over 2. First, from 0 to 2, all right, plus the second solid will be 2 to 9 over 2. Both integrate with respect to x. And now we need to put in the function. For the first solid, which is formed by this, this is the shape of the solid, formed by this quadratic curve, I need to put in the x squared plus 1. Alright, this is my y, and then we need the y squared to square it. And for the second solid, which is a shape of cone, this is a cone, it's formed by the the straight line that is 9 minus 2x. So the function need to be square. So that will be 9 minus 2x squared. Now we just find this integral, you will get the answer of the volume. So just you need to expand it first. You get x power of 4. After you expand both functions, you have this. And now you can start to integrate if you want. You can integrate x power of 4. You get x power of 5 over 5 plus the 2x cubed over 3 plus x. And put in your lower limit and upper limit. Then integrate this second integral. You have negative 1x minus 36x squared over 2 plus 4x cubed over 3. This is your limit. And here you can simplify it. You get 18 over here. Now you need to put in the upper limit and lower limit, calculate. Put in the 2, you have your 32 over 5 plus 16 over 3 plus 2. And if you put in the 0, all will be 0. So this term will be 0. And now for the second integral, you have your 9 over 2 put in. You got your 81 multiplied by 9 over 2 minus 18 multiplied by 9 over 2 square plus 4 over 3. And this will be 9 over 2 cubed. Alright? And put in the 2, you have your 81 multiplied by 2 minus 18 multiplied by 4 plus 4 over 3 multiplied by 8. Alright, then you can calculate with your calculator, get the answer. So after you have used your calculator to calculate all this, you should get 108.59 unit cube for the volume. This is the last question for this discussion. And we have given the f(x) equals to x sine 3x. We need to find the f prime x and f double prime x. Means that this is the first derivative, and you need to find first derivative and the second derivative. Double prime means second derivative. Hence, show that this statement is equals to 0. Alright, then now I would like to get my f prime first. To get your first derivative, I will use the product rule. Let the x become the u and the sine become the v. Okay, so to get the f prime x, I apply the product rule. This is a v u prime. Okay, apply product rule. You have your u, that is your x. Differentiate the v, get the v prime. V prime is differentiate the v, you got a 3 cos 3x. Plus, copy down the v, that is your sine 3x. And differentiate the u, you get 1. So you have your 3x cos 3x plus sine 3x. This is your first derivative. Second derivative, that is your f double prime. So for the second derivative, I will take this as my u, this as my v. Yeah? Alright, then I apply the product rule for the first term. Second term, you just direct integrate by using the formula. Okay, so integrate this first term. I copy down the u first. That is my 3x. Copy down the u and multiply by differentiate the v. You got a negative 3 sine 3x. Alright, and plus copy down the v. You got a cos 3x. Multiply by differentiate the u. You got 3. Okay, so this is the result of you differentiate the first term only. To differentiate the second term, which is your sine 3x, differentiate sine 3x, you got 3 cos 3x. Alright, then you need to simplify. Simplify, you get negative 9x sine 3x. Okay, this two term is the like term. 3 cos 3x plus 3 cos 3x, you got a 6 cos 3x. So now I'm going to prove this statement which x f double prime minus 2 f prime plus 9x fx plus 2 sine 3x equals to 0. So here this is the statement that we have left hand side consists of all this term and the right hand side is 0. I will prove it from the left hand side. The left hand side shown is x f double prime plus 2 f prime plus 9x fx plus 2 sine 3x. So don't write equals to 0 because this is just your left hand side. You're going to prove the left hand side equals to 0. So just put in your x, f double prime, you just put in what you got. That is your negative 9x sine 3x. Plus 6 cos 3x. This is your f double prime. Minus 2 f prime. F prime is going to be 3x cos 3x. This is what you got it here. F prime. Plus sine 3x. This is your f prime. Plus, I will continue down here. Plus 9x fx. Fx is x sine 3x. Alright? X sine 3x. X sine 3x. This is your fx. Okay. And after that, the statement is plus another 2 sine 3x. Now I'm going to simplify those terms. Okay. But before this, maybe we expand first. See, then later on, we see which like term can be combined. We have a negative 9x squared sine 3x plus 6x cos 3x minus 6x cos 3x and negative 2 sine 3x positive 9x squared sine 3x. This is the term from here. And plus the last term, that is your 2 sine 3x. So let's see which term can be cancelled off, can be simplified. Alright. So very obviously, this term and this term can be cancelled off. Okay, and this term and this term cancel off to be 0. And the first term and this term also can be cancelled off each other. So we say that this is equivalent to 0. Then we say that this is equal to right hand side. Then we can conclude that we have shown the statement to be true. Okay. Alright, so at the end of this video, okay, this is the set of past year question 2018-2019. For the next video, we're going to talk about, discuss on the past year question 2019-2020. Thank you so much for watching.